Okay, so for the first experiment, so for the part 1 of the experiment, so let's reset symbol, uh, hello. So, and excuse me. So here, so in this part, the data is stored in our RAM. So this is it. So we have our letters and a number sign 0 to indicate that it's the end. Print RS. Here print RS. So PC flash. So let's see. Okay, and then 7654. Okay, so here we are storing it. We are clearing the registers. And here we are multiplexing this part. So we have 0010 set B. Okay, so this is for the clock, I believe. So this part is the clock. And then we call the delay. After the delay, we set B. And for the this is for the clock again. Same function set B. So 1.7 going equal. So we will have 1010 at this point. So a clock again, and then delay, and then we enter in. So 000. Everything is 0. And clock cycle. Okay. We now have 0110. So 0110 right here. And then we have another clock set reset called delay. Wait for VF to clear. So this way is turned on, the course is turned on, making is turned on. So we reset again, and we have a clock, and then we set 1111, and we have a clock called delay, and then so and 3. Then sends the data. So I believe these are the data that is being sent. Send the data, okay. So it means it is ready to accept data. So okay. So this one enables the data to be sent. So at 1111, okay. So, okay. Then it receives the data here, displays the M, then loop move A at R1, move data pointed by R1 to A, okay. GC finish if A is 0, and then the data jump out of loop. So call the same character. Okay, same character. So same character. Increment onto the so after send character move C. So, Well, okay. So here in the first part, so we stored the data in our RAM. So this is the RAM location, and these are the values, the MAPOA and 0. So here, clearing pin RS to select register 02, instruction register for it. So this is register select. So if this value is 0, so it uses the instruction register, but if this is 1, then it uses the data register. And the function set, so I watched this video. So it's in order to access the displays right here where MAPOA is being printed, you need to set the function by doing this combination. So uh, we have here the combination 0010, which is the same as here 0010, and then that is to set the to enable the other what do you call this, enable the other uh, codes, or the 8-bit codes, to be modified. So here we first enable it to modify other functions, and then since our P1.2 is connected to our enable, and it is a negative edge, so that's why this is a clock tick. So set on off, so it's a clock tick. So to make sure that this one passes, enters, and we call the delay, so we wait for the BF to clear. So function set send for the first time plus module to go into 4-bit mode. So that is the uh, what this is doing. So basically we are uh, Intel 8051 is on 8-bit mode, so that's why we will go to 4-bit mode. So and then it will tick again to make sure that the high same function set high sent the second time. So okay. Then this is the low nibble, so we will set it again and wait for BF here. And here, this is the combination for the entry mode. This is the higher nibble. Set to increment with no shift, so 000, and we have a clock tick again, and we have the combination 0110, and that is for the entry mode set. Set to increment with no shift. So let's see. So here, entry mode, I think it's a different thing, but so here we just wait for VF to clear. Display on off control. The display is turned on, the process is done again. So okay, so that's this part. So display and cursor on off. So we turn them on. So that's why we have all on. And then our B blinking. So that's why it's all on here. And set B P13. Clears arrays indicates. So we swap from instruction register to data register. So that's why we are now using the number sign 30H. We are now accessing the at this part. Okay, so we have a loop. So this is to increment, how do you call this? To increment the RAM position here. So since we have here 30 until 35, so that's what it will do. And then the send character, it's just moving the uh, accumulator side here. This is the accumulator, and since the accumulator has 8 spaces, bits to store. So we have 7, 6, 5, 4, 3, 2, 1, and all of that will be moved to our uh, character display on the LCD. So we have C, P1, C, P1, C. Oh, wait. Hold on a second. So, so here we are moving the data from accumulator to C, and then from C to the pin port 1.7, which is basically moving things around from, from accumulator to 1.7, accumulator to 1.6, so on, until we reaches the 1.4, which is the last, or I believe it's the last. And then it ticks to make sure that everything works, and then we call delay and wait for VF to clear, and that's it. So let's answer the output of the program. So let's just take a screenshot of the output one by one. So assemble step and step. So I will fix this later. So, oh no, it's not pausing. Well, and A B there. Okay. Okay, so this is my answer for Q1. Of course, I will fix the format later. Let me check if I'm recording. And I am recording. So, at what addresses did you store the characters after returning? So that's our question 2. So let's go to our someone, copy the whole program, pick it, okay, copy paste. So use different file name. Okay. So let's do that. So 1.1. So let's call this one. So let's store my last name, which is Castillo. So let's see if this will work. Save and let's see, and change the delay to FFH. Unknown label FFH. Change the delay to, oh yeah, see, FFH. Yes. Oh, there. So I believe it took longer. So let me just copy paste my answer for that. That's it. So there. So I will fix the format later, of course. So what is the importance of including 0 and saving the data to RAM? So let's, for the sake of testing, so let's remove this and let's assemble. Let it run. So let's see what will happen if you don't have 0. Okay, so it's maybe it's because I didn't save it. So let's reset. Let's say overwrite this symbol set. Okay, so that is for the output. So let's see. Let's see. Okay. Okay, so after testing, I realized that the use of number 0 right here, uh, actually helps in the end of data marker. So as you can see here, oh wait, let me fix this. So usually 39 should be 40. So let's see what will happen if 0 is stored. So we have 37, 38, 54, 40. Okay. Um, okay, let's remove this one. So let's send that. So let's see. Oh, so it indicates that it is the end of the display. So let's put this in the middle of my name. So actually, let's adjust the numbers. So 35, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that. So the use of the 0 actually prevents the program from continuing the prints past the data marker. So that is my answer. Or, oh, I think so, so let's okay. So it should be 4, 5, 6, 8, 0. So the answer is it indicates that it is the end of the data marker. For example, if I have 0 stored in the middle of the program to print the values then stops printing. Printing the text. So that's transforming question 3. Skill 4. Okay. So I think I skipped a bit. We change the rate of FH. So, so, so let's see. So at around 10 milliseconds, we finished it. So let's try see. Page. Okay, so I believe it finished on this almost the same time. So hold on a sec. Okay, so continuing for the question 4. What is the output of the new program? Is stated with a picture or with a drawing? So with that, I am going to screenshot every instances. Okay, so see. Actually, let me put it in pen. Okay, that's for A. Ah, no. Okay. Okay. Excuse me. Nice. Okay. Okay. So this will be. Okay. I will fix that later. So the delay becomes longer, but since the maximum that when you start in the in the register is FF. Despite the assignment of FFF, it will only accommodate FF, which is still bigger than 200, which makes the new delay longer than before. That's my question 5. So this is the output of the program. So for the part 2, so the part 2 is copy to save program in part 1, number 11. Okay. Display your name in reverse without moving this. Do not change the location of its characters. Use decrement instruction to point at the memory where the last letter of your name is saved. So make sure to move 0. Make sure to move 0 to another memory location. Okay. Okay. So let's save this first and foremost. So let's uh, so the instruction here is to move this. So let's move this to the first ideally. So it's so since okay. Yeah, make sure to move 0 to another location. Okay. So let's just put that 29. So we must modify our program here on the jump. So at R1, so we must modify this one to 38. So I believe no, it should be 37, and then we change this to tech. So I believe that completes our thing. So let's no error. OLLITSAC. Nice. So the change part is the what they call this, the loop. The instead of increment R1, we decrement R1, and of course we change the move R1 starting at 30. We change it to 37. So it's just like if we not change the location of surnames character. So we followed that. So we only move the location of 0. Is decrement where the last letter is C. Okay. Okay, so that's it. So we move our instruction 69 to 37, which is the last here. 37 for the O, and instead of increment, change to decrements. So, okay. What were the changes? So let's answer this first. So the end marker was first moved to the very to the smallest what do you call this? Smallest register number, in this case -1. In this case my first letter of my last name is stored in 30. So the end marker was moved to 29. So the value of R1 was modified. Instead of storing 30 h, so let's just put h here. I believe I put h, yes. So storing 30h, which is the location of my first letter of my last name. It is changed to 37h, which is the last letter of my last name. Inside it, in addition, inside the loop function, the instruction increment R1 was changed to decrement R1 to print the values in reverse. Inside the memory in reverse. So let's see. Delay, loop, that's fine, loop. Yes, so loop, increment, this register R1 points the location of the memory address. That is why it is modified in this case to achieve the desired result of reverse printing of my last name. Okay, so which protocol did you use decrement instruction to do? Okay, so I think attend the changes. So the part of the program that was modified was the R1 inside the loop function. It was changed to def R1 because the starting value of R1 is the location of my last of the last letter of my last name. This is to print out the let the values in reverse that gets sent that was sent of the set character function. Set of accessing the memory address of 37H and above with the use of increment, the memory address being accessed is is 37H and below until it reaches the N1. Okay, 50, not hexadecimal. So let's do that one. So since this is 200, let's set it to 50. Olitsak Castillo. Olitsak. Okay, so the delay becomes shorter because of the lower value 50. No, instead of FFH. So let's try FFH. So let's try quadruple FH. So H. So let's symbol and on. So let's actually write the so around if the original delay value of FFH, the runtime to complete the print out every letters is 10 actually is around 10 milliseconds when the delay is changed to 50. So be very fast, so we need to keep track of it. So okay, so around 3 milliseconds it completed um, it's already completed at around 18 seconds. Therefore, the delay becomes shorter also and immediately brings out the values. Yeah, so question 4. Question 5. What do you think is the minimum value of the time delay? Minimum value of time delay for you to be able to observe it. Minimum value. Minimum value. So for me, oh, okay. So at 50, you can still notice it. So keep in mind that we are still using 100 frequency delay. So let's try half of it. So 35. Assemble. Okay. So, let's reset. So I actually assemble. Okay. At 25 delay, you can still notice it. Minimum delay. So let's try half of it. Say 12. It's not actually half that. So, okay. So at 12 delay, we did not actually see any movements. So let's try 15. Error function set incorrect. They mean. Okay. So error function set incorrect. So let's try 20. Okay, at 20, we can still see it. Let's try 18. Simple. Okay, at 18, we can still see it. Let's try 16. 16, we can still see it. 15. Okay, at 15, we still can see it. So, let's try 14. So, keep in mind that at 12, okay, so I think we reached uh, the point of no printing, which is 14. Okay, so that's actually fun. Okay. At 14, there are no displays, but at 15, okay, so 15. So, at time delay 15 is the minimum value of time to observe the output. At 14 and below, all outputs are not observable due to its past. I don't actually know. Maybe it's due to fast printing. I believe so. That's for the question 5. So I think that's it. So for the remaining part, so for here, I will just take a screenshot later after this recording. So I think that's it for the LCD character display, which is the experiment 4. Uh, Liquid crystal display character generator, which is actually cool. So we're using the display right here to print out letters instead of the 7-second displays, because most of uh, my subject uses this. So it's refreshing to see that we can actually print out uh, letters or values in a much easier way, perhaps, because this one uses a binary combination, which is cool in its own, but it's also cool to know this one. So yeah, and yeah, so again, for the function set is to enable the 4-bit uh, 4-bit mode and to modify the printing. So here we also enabled the let's name also we enable those displays right here, which is where we set here right here set B set B set B set B. So this is the part where we enabled everything to enable this part of the so I think that's it. So I'm Carl Castillo from CPE108L section E01, and thank you for watching.